I'm Darren Dotson, Project Coordinator here at the Region 5 STEM Center, and I'm in the Scion Esports Arena powered by Lake Charles Toyota right here at the Region 5 STEM Center. You haven't checked this out? Definitely do so. But we're not here to talk about esports this week. We're here to talk about all things competitive robotics. Let's check it out.
Just come outside for the night. Take your time, get your life, shut it down.
Now, I know you all heard about robotics, whether it be in movies or games, or you may be competing on a robotic team yourself. And we here have many different type of programs when it comes to just ground-based robotics like what you see in front of us. We have underwater robotics. We even have drones, which is another robotic platform in itself. But before we dive deep into what we do here in Region 5 when it comes to competitive robotics, let's take a look at the future of robotics and some type of careers that may be available for you.
This week on 60 Minutes, our story is about Boston Dynamics, which is a cutting-edge robotics company. It was exciting to actually get inside Boston Dynamics. Nicole Marks, the producer, has been working on this literally for years. To get inside there, you get a little sense like you're peeking behind the curtain.
And Spot's about 60 pounds.
We interviewed Mark Raybert, who founded the company.
Boston Dynamics started on the set of this 20th Century Fox movie outside of LA called Rising Sun. Mm-hmm. And we were providing robots for the background of a scene in the movie.
But only you have the next generation of technology to do this kind of work.
And we were there for a week, and it was a week of hell.
Why was it a week of hell?
Because nothing worked.
You realized you had a lot more work to do.
We had a lot more work to do.
I think for a lot of people, when you see the videos of robots doing these things, I mean, it's clearly extraordinary and amazing.
It's crazy.
And to see it in person, it's really startling. It's almost like it takes a little while for your eyes to adjust to what you're seeing. These are machines, but because they are in animal form or human form, because their motion is so extraordinary, it's hard not to kind of anthropomorphize them. And undeniably, for a lot of people, there's also kind of a fear factor involved. I feel like every person who makes robots in movies always thinks it's going to be for the good. And I mean, I hate to say this, they usually end up getting killed by the robots themselves. You don't worry about that.
I mean, that's the movies. What can I say? I hope people can see outside that because, there's a huge opportunity for the good things robots can do for us. I think robots are going to be our helpers. They're going to keep people from having to go into very dangerous situations. We have a robot at Chernobyl making radiation measurements. I mean, do you want a person doing that? So whereas Hollywood might be focused on the risks, I think the opportunities are huge, and it would be a shame not to take advantage of those opportunities.
That's how you see the future of robots. I mean, it's helpers and working in environments that are not conducive to humans working in, or working alongside humans for productivity.
And in some cases, doing things people can't do because of strength or precision things. Yeah, I think that's what they'll be used for.
It's interesting to actually drive Spot. It's actually very intuitive and very easy. You can just kind of get it going in a certain direction, so you're not really kind of doing much of anything. And that was kind of probably one of the most interesting things about driving the robots.
I think there are three really key pieces in robotics. There's vision, there's mobility, and there's manipulation.
Kevin Blankenspor is one of the lead engineers at Boston Dynamics. It is interesting to see how difficult it is to get a robot to do even a quarter of all the things a human being can do.
Yeah.
I mean, all the things that we can do that we just take for granted. We don't even think about doing.
Finding a box is so easy for a human, right? You can walk in with no training and tell me where all the boxes are. It takes years of robotics development to actually be able to do that.
Years.
We've been working on all of the pieces, the vision, the manipulation, the mobility for 2 decades. And we're, it's the tip of the iceberg. We're just getting started.
The thing I came away with is just realizing how far robotics still has to go in order to actually be able to really mirror human movements or animal movements. Some of the engineers have had Spot in their homes due to COVID this past year, and they all say how large it is and how noisy it is in a home setting. Not something you realize kind of in a big workshop or outdoors. So 50 years from now, what's a robot going to look like from that Boston Dynamics puts out?
That's a tough question. There's no doubt that today's robots will look minimum compared to tomorrow's robots. I think the versatility of the robots will be greatly enhanced. I think that the ease of giving them a new task will be greatly enhanced. And you know, it won't be that long until you can talk to it like you talk to Alexa and tell it what you want it to do, and it will understand more and more about understanding what you have in mind given the environment it's in.
When you say not too far, what do you mean?
We've done experiments with talking to Spot. I don't think that's far away. I think having it understand complicated situations and what you mean is a little further out, but you know, in 5 years you'll see significant progress. And we're working on some designs right now to achieve some of that.
My name is Amelia Liu. I have the coolest job in the world because I get to play with robots for a living.
My name is Professor Jonathan Roberts, and science helps me make amazing advances in robotics. So a typical day for us is to go and visit a site. So we may go and visit a factory and we'll try and understand their problems. They often approach us because they've got problems that they think a robot can solve. So we'll go and see the exact problem, try and work out the crux of the issue.
And then from then on, my job is to then incorporate the robotics and build this machine together, whether in simulation or actually on the robot.
And try and prototype a solution for them.
So an interesting fact about my job is, as a mechatronics engineer, we often have to actually build things twice. The first time to just figure out what we actually need to build, and then the second time to actually build this thing.
What inspired me to get into robotics was, of course, Star Wars. I was just exactly that age, that I was 7 years old when Star Wars came out, and I saw R2-D2 and C-3PO, and I thought, yeah, that's what I want to do. So day to day here we use lots of cool technology. Of course we use robots, and as part of those robots they have interesting things on board like sensors. That might be camera-based systems, there might be encoders that measure the joints.
Using depth cameras, using LiDARs, using laser systems, but as well as using different types of end effectors for the robots, so all types of manipulators, grippers, suction cups, all that sort of stuff.
We of course also use 3D printers to prototype, and a lot of mechanical parts as well. There's a lot of special mechanical engineering that's done here when we need to do a special job. So some of the STEM activities that are relevant to robotics are mathematics, which is incredibly important. You really need to understand your maths to become an engineer. We're very interested in people that know computer programming. The modern era, and particularly robotics, is very heavily reliant on programming, and of course students these days do that at school, which is fantastic. We also need people that love building things, so mechanical engineering is a fantastic thing. Electrical engineering's vital, and electronics. Really robotics is a combination of all those things, so we tend to need teams of people to work together to actually build robots.
So to anybody interested in studying robotics, in high school I did the advanced level of mathematics and actually biology, funnily enough. But in university I actually studied a Bachelor of Engineering, majoring in mechatronics at QUT.
A lot of the people I work with are mechatronics engineers, and mechatronics is a blend of mechanical engineering, electrical engineering, electronics and computer science. I moved to QUT and became Professor of Robotics, and my remit there was to expand the robotics activity at QUT, and my passion now has become how to get manufacturing industry to adopt robotics, and this is particularly small manufacturing industries where they typically wouldn't use robots, and how they can adopt robots to help their business. So from school I went and did aerospace engineering at university, and I was fascinated by spacecraft design. I then moved on to do a PhD at the same university doing computer vision, and that was in the area of driverless cars. And my particular part of that was from your robot driverless car, how does that car see other cars? I then moved to Australia and started in the area of mining robotics and particularly vision systems for robots in mines so they could kind of see what they're doing. I then went into the area of underwater robots, flying robots. We started to do some of the first work in Australia on so-called UAVs, unmanned aerial vehicles, and we developed again vision-based systems for these helicopters to fly around all by themselves. I then moved to QUT and became a professor of robotics at QUT, and now I kind of have a very wide remit to investigate all sorts of robotics, and I'm particularly interested at the moment in robots that help manufacturing.
What I find fascinating about my job is all the diverse things that we get to do and being able to do my part in helping to revive the manufacturing industry in Australia.
I'm most proud of the fact that when we started robotics in Brisbane back in the mid-90s, it was a very tiny niche thing, and now it's a big deal. You know, Brisbane is pretty much the centre of robotics in Australia, and it's only growing.
So what I'm most proud of is the collaborative nature of all the work that we do here, and as well as the multidisciplinary teams that we get to work in, and how we all get to grow and learn from each other.
The ultimate question for me is how to build a robot that can learn by itself.
The history of robotics here in Region 5 actually goes way back. We did Lego Mindstorm in many of our schools years ago, but in 2018 and 2019, we presented with a new program where we got it started in each and every single one of our middle schools. That's VEX VRC. With this, we had each and every single middle school competing on a local level, building robots and going up against each other. Of course, COVID came, the hurricane came, kind of slowed things down a little bit. But once we got back up and running, we continued with VEX VRC. Following that, Phillips 66 came through with 2 years of big donations. The first year, $60,000, which helped us allow these bots right here. By the way, that's Bob, built by Micey Misimo's state championship bot. We put 2 of these robots in each and every single one of our elementary schools. That's 66 teams on top of the 11 middle schools that we already had. Followed up with a $75,000 donation to help continue getting these programs up and running and allowed us to extend to at least 5 high schools. Like I said before, we don't just do state championships here, and you may think, this is a small town when it comes to robotics, but no. And I want you to think about the sports in which you may compete in. When it comes to middle school and high school, when you're competing on a certain level of sports, let's say football or basketball, of course you compete locally. If you're good, you do compete against teams throughout the state, giving you the opportunity to become a state champion. And for most teams, it stops right there. Not with robotics. Not only do you compete against the best teams here, you compete against the best teams at the state championship, but once you become a state champion, we send you to Worlds in Dallas, where you get an opportunity to compete against some of the best teams throughout the entire globe. When I'm talking about this, think about the Olympics, but for robotics. When it comes to the elementary spots, we at least have half of the teams that compete for the state championship coming out of Region 5 becoming state champions. For middle school, since 2018, starting with Ventnor Middle School, we've taken every single middle school spot. High school, this is why we're talking to you all, because you up next, with teams like Barr, with teams at Sulphur, with teams with some of them coming from Washington Marion, one guy from Sam Houston, Vinton High School. We're looking to have some state championship spots coming out of here right now. With that though, let's dive deep in what I'm talking about with VRC and show you what separates this away from every other athletic program that exists out there.
The day before we got here, I could not sleep. That rush it gives you, the feeling of winning with your team, losing with your team.
When you get into the dome and you have almost 10,000 people and they're cheering and they're clapping, it's just an electric environment.
It's really just like an opportunity of a lifetime, and I would 100% recommend it to anybody and everybody.
If you've never been here, you have no idea. You can't fathom what's going on.
I am so excited to be back at the 2023 VEX Robotics World Championship here in Dallas, Texas. Everybody from all over the world is back again. We have over 50 countries participating over the next 2 weeks.
I'd heard a lot about VEX, but since I got here, it's even bigger than what I could have imagined.
The scale of it and the size of it and the production value of it is critical, because it's critical that this robotics STEM learning experience is celebrated as highly as some of these other sporting events.
to come in and hear all the excitement, to actually watch them put robots on a field, watch them fail, overcome that, watch them celebrate. It is like no other experience that you'll be able to see. You go to a sporting event, you don't get to go to the locker room, right? Here, you literally get to go to their pits, you get to hear their huddles.
The world is represented. I've already seen folks from Canada and the UAE and Japan and Australia and Africa. They're all coming here because they all have that same mindset of we want to show off what we can do.
To be third for our country, the Philippines, and to hold our flag, wear our barong in the Parade of Nations, it just felt really good and we were all really happy.
Well, honestly, it's just the diversity here, the inclusivity of everyone. I've gotten to meet so many new friends.
非常开心，我们可以向其他国家的一些小朋友们互相学习，然后互相配合。
Some of our students had never left the state of Nevada, and then they come here and they have alliances with people from around the world. It's an amazing opportunity for them to see what else is out there and what can they do with these skills that they've developed all year.
They're talking to each other, getting to know each other. Even if they speak different languages, by pointing, demonstrating, they can actually speak this language of robotics. And I actually think it tears down walls and builds up understanding because this community is more tolerant and appreciative of each other.
The earth is so big, but when we are in VEX, it's like we can see people from all over the world. We can talk to them. We can help each other, even like we're gonna play against each other.
Everybody's willing to help each other. It's not like top secret. Don't look at my robot. I'm not going to help you with this. The camaraderie with these guys have been fantastic.
During the next 2 weeks, over 3,200 teams will compete at the VEX Robotics World Championship, but only 16 will go home as world champions. Even if you didn't win the top robot award, you got an experience of a lifetime.
As they go ahead in their higher education, in their careers, they'll look back at this time very fondly and say, yes, that was the time I worked with a team from halfway across the world. And yes, we didn't win, but we did so much else.
One of the most important things that any elite performer needs to learn in their lifetime is the ability to get knocked down and get back up again. Resiliency is key. It's more important than learning how to design 4-bar mechanisms or write code. And that's the skill that 100% of the teams here at VEX Worlds are getting experience with in every single match.
These kids are really a battery recharge. It gives me hope that our future is going to be bright. You know, in a world full of negative messages and doom and gloom, when you talk to some of these kids here, they are driven, they are confident. You know, there is absolutely no limit to what they can accomplish and where they can go. And sign me up, I want to be part of that.
Welcome to the 2023-2024 VEX Robotics competition season and this year's game, VRC Over Under. Over Under is a head-to-head game played by 2 alliances, one red and one blue, made up of 2 teams each. The primary game objects in VRC Over Under are plastic acorn-shaped tri-balls with a primary dimension of just over 6 inches. There are 60 tri-balls total in an over-under match, 1 preload per robot, 12 on the field, and 22 match loads per alliance. There are 2 netted goals on opposite sides of the field. A 3-inch PVC barrier divides the field into a red offensive zone and a blue offensive zone. Each tri-ball scored in a goal is worth 5 points, and each tri-ball which makes it into an offensive zone is worth 2 points. Robots can pick up additional tri-balls from the field or retrieve them from match load zones that are in the far corners of the field. However, robots may only possess 1 tri-ball at a time. Matches begin with a 15-second autonomous period, where robots operate without input from their drivers. During the autonomous period, alliances must keep 1 robot in their offensive zone and 1 robot in their opponent's offensive zone. Robots begin with 1 alliance-colored tri-ball as a preload. This alliance tri-ball always counts towards the same color alliance as the tri-ball, regardless of where it is scored. The alliance who scores the most points during the autonomous period will earn a bonus of 8 points. Alliances may also earn an additional autonomous win point by completing certain tasks during the autonomous period. The 1-minute 45-second driver control period begins once the autonomous bonus winner has been determined. During the driver control period, robots are free to move about the field. However, if an alliance ever finds itself with 2 robots in the same offensive zone, this is called double zoning. While double zoning, tri-balls that are scored in an alliance's goal are no longer protected from opponent robots. The VRC over-under field also includes 2 sets of alliance-specific pipes on either side of the barrier. These are called elevation bars and are used at the end of the match for elevating robots. At the end of the match, each robot's height off the ground will be measured to determine their elevation tier. Elevation points will then be awarded based on each robot's tier relative to all other robots. For example, getting to Tier E could be worth as many as 20 points or as few as 5. Elevation tiers begin at the floor and they end above the elevation bar. VRC Over-Under can also be played in skills challenges, where one team competes against the clock, and the collegiate-level VexU competition, where teams design 2 robots using advanced materials. Check out the game manual or talk to your REC Foundation Team Engagement Manager for all the details. Official rules and game information for VRC Over-Under can be found at roboticseducation.org or vexrobotics.com. To register a team, find events near you, or ask a question on the official Q&A, please visit robotevents.com. Best of luck, and have a great 2023-2024 season.
Now that you've seen an inside look at what it looks like to be on the world stage of robotics, let's take a look and see what we have going on right now. If you don't know, we're in the heart of the robotics season. We've already finished 1 elementary school competition, the Halloween Open here at the Region 5 STEM Center, and we're halfway through our leagues where we have a middle school division and a high school division. Well, let's take a look at your school leaders here for the high school and middle school divisions. And here we go, your top teams from our high school and middle school division, also known as our blended league. Starting with our 6th place and first team with a winning record, 33750A, Stand on Business. Their students, one coming out of Sam Houston, another out of Washington, Marion, and another from homeschool. Ahead of them, and only ahead of them by autonomous points, are Therion Autonomo. Team 3184A, also with a 3-1 record coming out of Sulphur High School. Now moving on to our undefeated teams. Team 43146C, the Sea Dogs. A C team coming out of Barb High School. In 4th place, because they're losing by them all-time points. Ahead of them, Team 33705A, 5-star loading, featuring their robot ice cream truck, and our only middle school team here remaining undefeated. Students from a plethora of different schools, including private schools, public schools like Oak Park, and even some homeschool students. Ahead of them, due to the strength of schedule points, and the next undefeated team in 2nd place, Team 69403Z, Cinnamon Toast Crunch. Coming out of some of the reigning, some of the best teams in the state, Vinton High School. And ahead of them by win points, knowing how crucial those win points are, we have Team 43146B, Barb's Buccaneers. Right now sitting in a comfortable 1st place with 9 win points ahead of every other team in this division. Now, of course, that's just one of our programs, and we're talking about VRC. And if you don't know, we do have this available at just about every single middle school and most high schools. Still looking for a coach and a team in Sam Houston and Westlake. Don't know where you're at. Got it in Washington, Marion, but man, y'all gotta come on through. Starks, we're still working on you. But those who already know what's going on with robotics, we see you, and we're gonna see you here on Thursday or at the next competition. But enough about VRC. We have a professional level robotic program specifically for high school students. These type of programs, I'm talking about a bot that's 125 pounds. It costs us on average $20,000 to build this bot. And we do have one team right here at the STEM Center called the SWLA Tech Pilots. Let's take an inside look as they compete every single year at the Bayou Regional. By the way, in 3 years of running, they went to Worlds. And that's a record for a new team being able to do what they're able to do. Let's take an inside look. And if you're interested in joining this team, definitely reach out to them. They meet typically on Mondays, but I will be dropping that information in this video. Let's take a look right now.
How much
Casey. I'm here with FRC Team 4087 Voodoo Voltage, and right now we're at the Bayou Regional.
We've come here to Bayou Regional to finally get another chance, another shot at reaching the first world.
And we're here today at Bayou Regional, going to compete and looking for a competition win.
We're CB Buds and we come from Mexico. We are here because we enjoy robotics so much, we love it.
We love doing it because a lot of us want to go into this type of career path, engineering, technological and all. And also, we're just here to have fun and just learn in the experience, you know.
Seeing all these kids doing things that they've never done before. And it told me that this was the right thing. We were in the right place. We've got seniors that didn't know where they wanted to go this year. They've got all these dreams because they know that they can come true now. I'm amazed at how FIRST works.
What I really like about FIRST is that it really creates an amazing environment for people who don't normally have the opportunity to learn about STEM.
One of the reasons that I'm on robotics specifically is because I've always been interested in the STEM field. I want to be a mechanical engineer when I grow up.
I know I'm going into engineering in the future. For us, this competition means a lot.
And we're all here working together. We've spent the past 2.5 months creating this robot that we're all really proud of.
You can do robotics. Robotics is an opportunity for everyone. So there's no better place to be.
Being able to come out here, make a bot that can do amazing things, and enjoying the matches, the people, the family, it's a community. It's a wonderful time.
I've learned a lot this year, just helping build the robot. It's just a great experience overall. It's really rewarding to see what I individually did and what as a team we were able to do together.
I'm Heather. I'm part of Team 3616 Phenomena. Me and my team, we're like a huge family. We're all very close to each other. We've spent every day almost together, and really think that it's friendships that'll last.
Learned through FIRST. But as you do it as a group, that's the only way to inspire and recognize the talents that we have to learn the science and the technology of today. I can't say enough about FIRST and how much it's improved the students that we have now that were struggling in school at the beginning of the year that are now making straight A's. Because of FIRST, because of robotics, that's happening right now.
I just want to really thank our sponsors. Our whole team is incredibly grateful to y'all. You've really made all of this possible. We never could have done any of this without y'all. You mean so much to us. They're all vital parts of this club, and we couldn't have done it without y'all.
Drivers behind the lines. 3, 2, 1, go.
Match 27 on the Newton division, presented by Ford. All 6 robots moving across the field, and they've been placing game pieces in their grids. Those are worth extra points during the first 15 seconds of the match. Both alliances having 1 robot docked and engaged. That's 12 points added to their score. Blue Alliance trailing by 7 points as drivers are now at the controls. Bedford Express, Cone scored on their middle row. 88-08, this time Cube scored for that alliance. Blue Alliance robots trying to find more game pieces that they can score in their grids. 56-65 scoring in their co-op grid. That's Spark from Istanbul. 35-72 on the Blue Alliance, trying to play some defense in the middle of the field. That's a Wavelength. Red Alliance robots looking to score 2 cones, 1 on the middle and 1 on the top, but it ends up on the bottom row from 56-65. 15-38 reaching up. The Holy Cows looking to place a cone, and they do so. 2 robots on our Blue Alliance, our Michigan Alliance, scoring on both in their co-op grid. Both alliances have 2 links scored apiece, looking to get 5 total so that they can earn an extra ranking point. Red Alliance with the lead, 88-82, 54 seconds left to play. 494, the Martians cone, looking to score it on their top row in their co-op grid, and they do so. Blue Alliance with 4 links. Now Red Alliance also with 4 links. 1 more completed and they will earn an extra ranking point. Red Alliance does this, but we have less than 30 seconds left in the match. Scores are close, 117 to 118 in favor of the Blue Alliance. 2 robots apiece are right around their charge station. Can they end up docked and engaged at the end of the match? Now 3 for the Blue Alliance. Red might also be trying for all 3 robots. Red Alliance with a 7-point lead, 5 seconds left. All 6 robots docked and engaged on their charge station as we end match number 27. 157 for the Red Alliance with 4 ranking points. Blue Alliance ended with 150 points and 2 ranking points. Both alliances earning the extra ranking points for the activation bonus and sustainability bonus.
Now, I know we got many athletes out there. Y'all have good times at your basketball games and football games. I know it. DJ and I MC those myself. But there's nothing like coming to a robotic competition. Seriously, it's like battle bots for kids. If you don't believe me, come here this Thursday and you will see for yourself. If not, we got more opportunities coming up in December. LeBlanc, December 9th, their holiday open as well, followed by Barb, another big competition where 32 teams throughout the state will be coming here to the Region 5 STEM Center, competing for the opportunity to get a ticket to the state championship. Until next time, next week, we'll be diving deep into, the strategies about some of these teams, also as well giving you all an opportunity to program and see exactly what it's like to be part of a robotic team. Until next time,